Morning again, ladies and gentlemen. It is Wednesday, May 15th, second day that I'm gone here. The pancreas is the topic of day seven's discussion here on this Wednesday. It is a day one in Cold Lake, so we'll chat with you guys in a little bit about alternative activities here. The pancreas, this section of the endocrine system, is found on page 254 of the textbook. The pancreas is a long, slender organ that functions both as an exocrine and an endocrine gland. In terms of exocrine, pardon me, it assists in the digestion of food. It secretes digestive enzymes that are activated in the duodenum that stimulate the breakdown of those proteins, lipids, and carbohydrates so that they can be absorbed. It also secretes two hormones that affect that are part of the endocrine system. Insulin, which is the most common one, and one that's not as known as well as much as is called glucagon. These are secreted in the what are called islet cells or the islets of Langerhans. There are two different types of islet cells. There are alpha cells, which secrete glucagon, and there are beta cells, which secrete insulin. In the last 5 years, there have been at the University of Alberta Hospital uh, major breakthroughs in islet cell transplants in type 1 diabetic patients, where islet cells from donors who are closely matched are implanted within the beta cells of the islets that essentially hopefully take over for the damaged beta cells in the type 1 diabetics and begin to manufacture effective insulin once again. And that the key word there is effective. As with type 1 diabetics, their insulin secretion is no longer effective for one reason or another. It no longer works. So, anyways, this is got leaps and bounds going in the right direction for type 1 diabetics. So insulin itself, this is released in response to increased blood glucose levels. So again, those chemoreceptors, which are distributed throughout our circulatory system, as soon as the monosaccharides are absorbed in the duodenum, elevates blood glucose levels. In response to that, insulin is secreted. This decreases as glucose levels decrease in the blood as well. The insulin exerts a widespread effect, and its target tissues are all the cells of the body. It transports glucose into most cells, and most is the key word there. Without it, glucose remains in the bloodstream, and the patient becomes hypoglycemic, and over a long period of time, a patient can slip into a diabetic coma. As a result of the metabolism of fats and proteins, diabetic patients or patients who are chronically hypoglycemic can also develop a condition called diabetic ketoacidosis, where ketones build up within the blood from metabolism of proteins and fat and render the blood acidic as well. Insulin helps to control carbohydrate, protein, and fat metabolism, and it stimulates the breakdown of glucose for energy. Stimulates the liver and skeletal muscles to store glucose as glycogen. And that's an interesting term and to remember is that glycogen is what animal carbohydrate is stored as. If we eat, most of the sources of our carbohydrates are as plant carbohydrates, starches from potatoes and peas and so on, legumes. Um, the fruit that we eat, oranges, apples, bananas, pears, all of those things, that's all stored carbohydrates in a fruit form. It's more close to sugar that we more closely related to sugar that we can compare, but those carbs that are stored as carbohydrates in an animal are stored as glycogen. The insulin also increases transport of amino acids into cells as well, so it stimulates muscle growth, stimulates synthesis of protein from those amino acids and the making of fat from fatty acids. Okay, so it's what helps our muscles get built up and storing of extra fatty acids as fat. Insulin decreases blood level glucose for two reasons, and it's the only hormone that does this. It increases transport into the cells, and it stimulates those cells to burn glucose as fuel in the Krebs cycle, as you guys have studied in the past here in other classes, and as we've mentioned in the past, in anaerobic metabolism. The only hormone that lowers blood glucose is insulin. Okay, it's insulin. So diabetes mellitus is a widespread disease that is essentially a deficiency of insulin that causes severe metabolic disturbances. Insulin deficiency or ineffectiveness is called diabetes mellitus, also referred to as the melting down of flesh and limbs into urine in past years, which essentially is what exactly happens. The sugar that the patient consumes goes into the bloodstream. It can't get out of the bloodstream into the cells because the insulin isn't there to transport it. It therefore builds up into the circulatory system. The kidneys try to decrease the circulatory sugar by excreting it in the urine. This takes huge amounts of water and leads to dehydration. The patient's cells need energy, and so it turns to its fats and it burns that fat off, leading to acidic buildup of ketones in the blood, a decrease in body fat. When the fat is gone, it starts to metabolize proteins, our muscle. So it melts the fat and the muscle into urine, and off it goes. Interesting note, and this will gross you out a little bit. Brooklyn, plug your ears if you don't want to listen. Anyways, before there were blood glucose tests in the early 1900s and late 1800s, they understood something was going wrong, and physicians would actually taste the urine of the patients, and it would be very, very sugary, very sweet, because the kidneys are excreting huge amounts of sugar into the urine. Hyperglycemia is a condition of excess blood glucose. Two factors cause it. Number one is the inability of glucose to enter the cells, which is a failure to move glucose, causing it to accumulate in the blood. And this is as a result of the ineffectiveness or inefficiency or lack of insulin. Or second, it's the manufacture of additional glucose in an attempt to fill the needs of the cells. So that gluconeogenesis we talked about at the beginning of the program and so on takes place, turning the fat and protein into glucose to try to take the place of the glucose. Our body does this because it thinks it's starving, but it doesn't realize that there's so much sugar in the blood already. It doesn't need to do it, but it needs energy. So this accumulates even more sugar in the blood, manufactured from proteins and lipids in the body, causes a melting away of muscle. The glucose just can't be used, and it has to be flushed out in the urinary system. Now, this urinary flushing is exceptionally hard on kidneys. Chronic hyperglycemic patients will often undergo kidney failure early in life. Poorly maintained or non-maintained diabetics wear their kidneys out, trying to as their kidneys try to balance the blood sugar or try to rid the body of the sugar in the blood. You can think of sugar as like sand, very abrasive. It's very hard on the nephron units within the kidneys. The kidneys are meant for moving some potassium, some sodium, some calcium, some sugar, some other electrolytes around, but not in the amounts that diabetics with hyperglycemia are trying to move, and it damages the nephron units. We've only got about 1 million nephron units in each kidney. We start damaging them, the scar tissue is no longer able to filter the blood as adequately as it's supposed to, and we end up on dialysis, which is never a good thing. So glucosauria is glucose in the urine. It takes place to dispose of the sugar. It's a chronic condition causing kidney failure. Patients that are hyperglycemic and can potentially be in ketoacidosis have to urinate on what are called keto sticks, because ketones, the ketones that are produced when we metabolize our fat and our protein, are also disposed of in the urine, because the kidneys just do that. They try to excrete the nasty stuff out of our body to get rid of it. These ketones they cause our blood to be acidic, and they are detected by the keto sticks. Now, there's another condition called polyuria, which is an excessive excretion of urine, which takes place in patients that are hyperglycemic. They're constantly urinating as their body constantly producing more and more urine to try to get rid of the sugar. Polydipsia will accompany the polyuria. As you're urinating all the time, you're getting excessively thirsty because you're becoming dehydrated. Polyphagia is excessive eating. Our body becomes hungry to take in more carbohydrates because it thinks it's starving. But as you take in more carbohydrates, those sugars additionally go into the circulatory system, causing a more exacerbated hyperglycemic situation again. Acidosis. This is the blood becoming acidic from the burning of fatty acids instead of glucose. Ketones are released, leading to this acidosis. Some signs and symptoms are a fruity odor of the breath, and it's caused by the rapid and incomplete breakdown of fatty acids to nourish cells instead of glucose. It's like burning diesel in a gas engine, and that all lets a whole bunch of smoke out, and it's just nasty, ugly. And instead of smoke, we're releasing ketones in this case here. These are some of the symptoms that led me to discover my daughter's diabetes. She was excessively thirsty, drinking basically beer pitchers full of water and what do you call it, iced tea to try to slake her thirst, and she just couldn't do it. So insulin receptors. Now, this is associated with type 2 diabetes. A lack of insulin usually causes diabetes. Some situations develop because of insulin receptor damage or diminished numbers of receptors. Receptor damage takes place, therefore the receptors cannot be stimulated when they're exposed to insulin, or the patient will become hyperglycemic as a result of the insulin receptor damage. Hyperglycemia triggers the release of additional insulin and has a whole full cascading effect, building up more and more insulin within the circulatory system, but none of the insulin is effective. A diminished number of receptors takes place because of obesity and lack of exercise. This can lead to a diminished number of receptors available for the insulin, so the blood sugar builds up. Secretion of insulin is normal, just not as many sites to accept that insulin. Therefore, the blood sugar builds up because there's not as many cells receptive to the insulin. Weight loss and exercise reestablishes these sites and relieves the symptoms. The next main point that can lead to diabetes, and this is type 2 diabetes, excess fat tissue secretes hormones that actually oppose insulin and cause insulin resistance. So the insulin that's being produced should be sufficient, but the adipose or fat tissue that is on the person's body is actually secreting hormones to counteract the insulin. Now, glucagon. This is secreted by the alpha cells, and it increases blood glucose levels by stimulating glycogen to convert to glucose within the liver. That's taking the animal carbohydrate, converting it into a sugar molecule, and stimulates the conversion of proteins into glucose in cases of starvation. It's used clinically to treat hypoglycemia, and my daughter carries a glucagon injection kit that she can use in cases of hypoglycemia. If she doesn't have adequate food to eat, she can inject herself, or we've taught her friends to inject her as well in cases of hypoglycemia. If she goes into a diabetic shock, she can basically give her liver a shot, and that shot will squeeze out a little bit of glucagon into glucose and allow her to continue to perk along until she can get some food. Infection is also something interesting as well. If a patient is diabetic and they develop an infection like any kind of an inflammation like pancreatitis or anything like that, the flu, for example, diabetics are very prone to infection because of the high levels of sugar in their body. Infection increases glucagon secretion. Okay, so it elevates their blood sugar. This glucagon secretion stimulates the liver to release more glycogen into glucose, and therefore they will have chronic high numbers, chronic hyperglycemia. Infection stimulates the secretion of all stress hormones like epinephrine, cortisol, growth hormone, and all of these elevate blood sugar, causing the patient to become hyperglycemic. Even though they're not eating it, the sugar is being secreted by their storage units, okay, basically the liver, to increase blood sugar. Patients that are type 1 diabetic have to inject more insulin and really watch their numbers. They have to take tests fairly often. Okay, that brings us to the end of today. Again, another short lecture time here. Today, you guys need to have a look at page 257 through 259. That's looking at the gonads, or the male and female reproductive organs, the thymus gland, the pineal gland, and other hormones. So this takes us to the end of the program. It'll be another brief lecture tomorrow and some work time. Um, Today is day 7. So having a look at those readings, there is no questions assigned today. However, you do have the recipe card mind map and research project that you can spend some time working on as well. So have a great day, and we'll see you guys all on Monday.